Section 7.7, Exponential Growth and Decay. Exponential growth occurs when a quantity increases by the same rate r in each period t. When this happens, the value of the quantity at any given time can be calculated as a function of the rate in the original amount. So if we're calculating exponential growth, we're going to be looking at using the formula or equation y equals a times the quantity 1 plus r raised to the t power, where y represents your final value, a represents your original amount, r is your rate of growth as a decimal, and t represents time. So first example, the value of Mr. P's autograph is $9,000, and the value increases by 7% each year. Write an exponential growth function to model this situation. Then find the autograph's value in 15 years. So right now we're going to look at modeling this with an exponential growth function and then figuring out the value in 15 years. So right now, this is our original value, so that's A. Our rate is 7%, and our time in this case is going to be 15 years. So the general form for exponential growth, remember, is A times 1 plus r raised to the t power, or the time. So we're plugging in what we know. Well, we're looking for final value. We know the initial value is 9,000 times 1 plus 7% as a decimal, so 0.07, raised to the power of 15. So in this case, we want to plug this into our calculator. And when we do that, we should get that the final value of the autograph after 15 years is $24,831.28. Question 2. A sculpture is increasing in value at a rate of 8% per year, so that's our R. Its value in 2000 is $1,200, so that's our A value. And we want to write an exponential growth function to model the situation. Find the sculpture's value in 2006. Well, if they're starting in 2000 and they're moving to 2006, that means our T value is going to be 6 years. All right, so now we have everything we need. So we'll take y equals the initial value A times 1 plus the rate raised to the t power, which in this case would be time. All right, so we'll plug in what we know. We're looking for the final value. The initial value is 1,200 times 1 plus the rate is a decimal, so that's 0.08 raised to the 6th power. So once again, we're going to put this in our calculator. And plugging that in, we should get that after 6 years, the sculpture is worth $1,904.25. Next, exponential decay occurs when a quantity decreases by the same rate r in each time period t. Just like exponential growth, the value of the quantity at any given time can be calculated using the rate in the original amount. So for exponential decay, we have a very similar equation. It's y equals a times the quantity 1 minus r raised to the t power. So the only difference here is we're subtracting the rate instead of adding it. And our a value is still our original amount, r is still our rate as a decimal, and t is still time. So let's calculate exponential decay. The population of a town is decreasing at a rate of 5% per year. In 2000, there are 1,700 people. Write an exponential decay function to model this situation. Find the population in 2012. Well, we know that the rate is 5%. We know the initial value is 1,700, and we're going from 2000 to 2012. So that means the time is going to be 12 years in this case. So we're going to plug this into our exponential decay function. So y equals a times 1 minus r raised to the t power. And now we plug in what we know. We're looking for y. The initial value is 1,700 people. 1 minus your rate, well, your rate is 5%, so 0.05, raised to the t, or in this case, 12th power. So So once again, you want to put this in your calculator to figure out how many people are left after 12 years. And after 12 years, we should have right around 918.6 people. We can't have partial people, so you could say 919. Or if you wanted to round down because it's kind of on the decrease, you'd say 918 people. All right, the number of hairs left on Mr. P's head is decreasing at a rate of 3% per year. The original amount was 48,000 hairs. Write an exponential decay function to model the situation. Then find the number of hairs left on his head after 7 years. So evidently Mr. Pelzer, or Mr. P in this case, is going bald. And so we're trying to figure out how fast he's going bald. So the rate is 3%. The initial value is 4,800, or 48,000, sorry. And then the time, or t in this case, is 7. So we're setting up our exponential decay function. So a times 1 minus r to the t power. So we're going to plug in these values. So y equals our initial value of 48,000 times 1 minus the rate, so 0.03, raised to the t power, which is 7. So once again, we're going to plug this portion into our calculator. And so when we do that, we should figure out that after 7 years, Mr. Pelzer has 38,783.18 hairs left on his head. So he's not quite bald yet, but he's getting there. A common application of exponential growth is compound interest. Recall that simple interest is earned or paid only on the principal, where compound interest is interest earned or paid on both the principal and the previous earned interest. So in order to calculate compound interest, we use the formula A equals P times the quantity 1 plus R divided by N raised to the N times T power, where A represents your balance after so many years, T is your principal or original amount, R is your rate, N is the number of times something is compounded yearly, and then T represents the number of years. Quick point of reference, the word annual tells us that something is being compounded once per year, so your N value will be 1. Quarterly means 4 times per year, so N would be 4, and monthly means 12 times per year, so N would be 12. So, write a compound interest function to model each situation. Then find the balance after the given number of years. So they have the initial value, in this case our principal is P. It's invested at, so 1,200 is invested at a rate of 2%, which is compounded quarterly, so that means N is going to be 4. And they want to know what the value will be after 3 years, so T is 3. So we use our compound interest equation. So remember that's A equals principal times 1 plus, in this case we're going to take R divided by N and then N times T. So we want to plug in what we know here. Well, we're looking for the amount. We know the principal is 1,200 times 1 plus the rate, which is 0.02. It's compounded quarterly, so 4, and then you have 4 times 3 years. And so this is what we want. But before we plug this in our calculator, let's just try simplifying down what's in the parentheses first. And so for this one, if we simplify it down, we get 12,000 times 1.005 raised to the 12th power. Now that I've simplified that down, I can put this in my calculator, and I should get that after 12 years, we currently have $1,274.01. All right, question 2, same idea. We start with $15,000. We have a rate of 4.8. It's compounded monthly, so that means N is 12, and we're looking for over 2-year period. So we start with our compound interest equation. And so we plug in what we know. Well, we know that our principal is 15,000, and 1 plus 0.048 divided by 12 times 12 to the 12 times 2 power. So we can simplify what's inside our parentheses to start off with. So we've got 15,000 times 1.004 raised to the 24th power. So plugging this in our calculator, we find out that after 12 years, our total value is now $16,508.22. All right, third problem. Another compound interest question. This time we are talking about starting with $1,200 invested at a rate of 3.5, compounded quarterly, so that means N is 4, over 4 years, which would be T. So we start with our compound interest equation, P times 1 plus R over N raised to the N times T power. Plug in what you know. Well, we know the principal is $1,200. We've got 1 plus 0.035 divided by 4 raised to the 4 times 4 power. I will simplify what's in the parentheses first just to make it a little easier here. So 1 plus this, we end up with 1.00875 to the 16th power. So this is what I want to put in my calculator. And so after 4 years, our value is $1,379.49. All right, last problem. This time we start with an initial value of $4,000, so that's our principal. We have a rate of 3%, compounded monthly, so N equals 12, over a course of 8 years, so that's T. So we've got A equals P times 1 plus the rate divided by how often it's compounded, raised to N times T power. That's right, we're going to plug in what we know. Well, the principal is $4,000. We've got 1 plus 0.03, and then compounded monthly, so that's 12, and then 12 times 8 power there. We're going to go ahead and simplify this a little bit, clean it up. So we've got 4,000 times 1.0025 to the 96th power. So this is what I want to plug into my calculator. And so when I do this, I get that the value after 8 years is going to be $5,083.47.